So we're going to continue here. We're going to verify some polynomial identities. So essentially what we're going to do is verify an identity by simplifying one side of the equation to match the other. So you take the bigger side, you expand it until you can simplify it to match the smaller side. So if we look at this one here, you notice the one on the left is really big, so we want to simplify it and make it smaller. So we have to simplify the left side. We're going to multiply as we have been doing. So first they took a times a squared. Now they'd take a times the middle term on the right, negative ab, plus a times b squared. Then multiplying b times each term. So b times a squared, b times negative ab, plus b times b squared. Combining like terms here and putting them in order of power. What is it? B cubed. Doing some simplifying here. Minus a squared b. Putting them all together. Notice all of our middle terms here are going to cancel. We're left with a cubed plus b cubed. And so we've simplified it and proven the identity by creating a true statement. So we want to do the same idea here. We're going to expand this the right side, until we can cancel out terms and get to something that's more simplified. So we'll have to take a times each term. So a times a to the fourth plus a times a cubed b plus a times a squared b squared plus a times ab cubed plus a times b to the fourth, and then plus negative b times a to the fourth plus negative b times a cubed b plus negative b times a squared b squared plus negative b times ab cubed plus negative b times b to the fourth. So you'll notice come up with a to the fifth plus a to the fourth b plus a cubed b squared plus a squared b cubed plus a to b to the fourth minus a to the fourth b minus a cubed b squared minus a squared b cubed minus a b to the fourth minus b to the fifth. All of our middle terms here are canceling, so we're just left with a to the fifth minus b to the fifth, and thus we've proven the identity, because that is a true statement. We've made the two sides equal each other. We'll do the same thing here, this time on the left-hand side. So we'll take a times a squared plus a times ab plus a times b squared plus negative b times a squared, negative b times ab, negative b times b squared. So that gives us a cubed, a squared b, ab squared, minus a squared b, minus ab squared, minus b cubed. Again, the middle terms are canceling. We're left with a cubed minus b cubed, which is the same thing as the right-hand side of the equation, so we have proven the identity. We can use some of these identities to do some easy mental math tricks. So here we're going to do that with some examples. So the identity x plus y, that quantity squared, is equal to x squared plus 2xy plus y squared. You can use that for some mental math calculations. So if we want to find the square of 27, we want to pick some nice numbers that we know the values of. So if we let x be 20 and y be 7, so our x plus y squared would be 20 plus 7 squared is equal to this piece here. So our x was 20, so we take 20 squared plus 2 times x, which is 20, times y, which is 7, plus y squared, which is 7 squared. 2 times 20 times 7 is 280. Adding those three pieces together, we'll get 729. You can confirm it with a calculator. So we're going to use this identity here. We want to find the product of 37 and 43. So if we notice, those two values are both 3 away from 40. So if we let x be 40 and y be 3, we take 40 plus 3 times 40 minus 3. This should equal our x squared minus our y squared. That's 1600 minus 9, which is 1591. So the key is to pick the nice numbers you know should come out easily for you. We're going to use this identity to find the square of 18. So again, we want to think of some nice numbers. So if we let x be 20 and y be 2, then if we take 20 minus 2 squared, because that's 18 squared, should be x squared minus 2 times x times y plus y squared. That's 400 minus 80 plus 4, which gets us to 324.